Hello, welcome to Flipped. So today we are on the topic of fuels and crude oil. But we are in the second chapter, which is the describing of petroleum as a mixture of hydrocarbons and its separation into useful fractions by fractional distillation. Okay, so in the previous video we told you that petroleum is actually made out of a lot of things, right? They are called hydrocarbons. Okay, just let me write HC for short. Okay. How to actually best visualize them? Okay, let me give you an example. So imagine I have some marbles here. Okay, these are green marbles. Then I have yellow marbles. Okay, let me just draw. Then the final one is pink marbles. Alright. Okay, they are all in this, maybe this bag together. Okay, so as a whole, they don't do anything for me. They are useless in this whole bag mixed together. So what I want is, I want to separate them. I want to take out all the green colors, okay, and put them one side. I then want to take out for example, the pink ones, okay. They are all here, right? Then I want to put them on this side. And finally, I want to take out the yellow ones, which is this one or this. I want to put them on this side. Okay, so essentially this is what the fractional distillation is. You're basically unmixing a bucket of mixed stuffs, for example. In this case, it's marbles. But in the case of petroleum, it's actually fuels, okay, to burn. So really, the whole point of this chapter is actually quite simple. It's really just to break them up into fractions. Okay, so how is it done? Okay, this is actually very simple. It's done in a fractionating column, which you will see later. Okay, it separates hydrocarbons into their useful fractions. Okay, so if anything, just remember this, and it's based on their boiling point. Okay, so what do we mean by that? Okay, so it's actually quite simple. Okay, so imagine you have a kettle, for example. Okay, a kettle. Okay, my drawing is not very good. Okay, so you have fire here. Okay, so when does it actually boil? Okay, it looks like a tank, but actually it's a stove. Okay, it's a kettle. Okay, so when does your water inside boil? Okay, when it reaches the boiling point, right, which is 100 degrees Celsius. Then what happens? Okay, the water will convert into gas. Then you will just steam out. Okay, you'll make the sound, correct, for you to turn off your stove. Okay, so this is the same process here, but imagine you have more than one kind of liquid in your kettle. Okay, so when it reaches, for example, 100 degrees, the first kind of liquid, okay, call it the pink liquid, will vaporize, which means it will convert to gas. Then maybe at around 150 degrees Celsius, then the blue liquid will come out. Okay, and this is what we mean by separating them into their fractions. Okay, so this is a very simplified form of the fractionating procedure. Okay, so we will go into detail now. Okay, so this is the process actually. Okay, this is a very small model of fractionating column. Okay, because we'll go deep into detail later, which is part C. Okay, but let me just run you through the process. First, okay, you have to put petroleum here. Okay, it's usually a big, like a well or something. Okay, then you heat them up. You heat this petroleum up so it enters the chamber here. Okay, this is called the fractionating column. Okay, so the first step is to heat. Second, when you heat this thing up, different fraction vaporizes at different boiling point. Okay, so please remember our kettle example. Okay, so different temperature, different colors of liquid come out. Okay, we'll go into the fractions in detail later, but this is just a rough guideline. Okay, so at different boiling points, different fraction vaporize. Okay, for example, at around 40 degrees Celsius, okay, this pink color liquid that's inside the whole mixture will come out first. Okay, then the blue one will come out, for example, at 110 degrees Celsius. Okay, I know the words are a bit small, okay, but this is not so important for now. You just have to know the rough flow of it. Okay, so this is what I mean. Different fractions vaporize out at different at different boiling point. Okay, so this is done also. Then different fraction condenses out of the fractionating column at different heights. Okay, so what do I mean? Condenses means what? Okay, it means really just from gas phase to liquid. Am I right? Okay, so what does this mean here? So when, for example, my pink gas, okay, my pink substance, okay, my pink fuel, it's being heated up. Okay, so this is step 1. Then it goes to step 2, right? It vaporizes. It goes up here. Now what happens? It's still in gaseous phase, right? So it has to condense. So usually there's some special technique being applied here. Okay, you don't have to know. Okay, so when a gas is run through this technique here, it becomes liquid and it gets stored here. Okay, so for example, it gets stored here. Okay, and that's what we mean by different fraction condenses at different height. Okay, because for example, we take the blue one for example, it goes through step 1, heat, then after that vaporize. Okay, then it condenses here now instead of this part with the pink. Okay, it has its own height to be condensed out of. Okay, and the rest applies as well. Okay, so this is what we mean by different fraction condenses out at different height. Okay, next one, we'll go into detail. The heavier the fraction, okay, higher boiling point, and it comes out the nearer of the column. If it's lighter, it's lower boiling point. It comes out nearer to the top of the column. What do I mean by this? Okay, let me just give you 2 examples. Very simply, I give you 2 animals. Okay, so for example, we have a pig here. Alright, this is a pig, right? Okay. This is not drawn to scale, okay, of course. And let's see, a fish. Okay, let's just ignore this for a while. Let's just look at a pig and a fish. Okay, this is I think is the rough size. Okay, if not drawn to scale, but between them is I think roughly the same size, roughly the correct dimensions. Okay, so a pig is heavier, right? Would you say so? It's heavier. Okay, so it has higher boiling point. Okay, so this one, and it comes out nearer to the bottom of the column. So for example, if a pig and a fish are both stuck in a well, correct? Then if I have air blowing up here, okay, which one will go higher? Obviously, the fish will go higher, am I right? Whereas for the pig, it will just go a little lesser. Okay, and that's what we mean actually, if you if you reconsider this whole process. Heavier fraction, okay, it will come out nearer to the bottom of the column. Whereas lighter fraction, like the fish, will come out to the top of the column. Okay, hope this is clear. Okay, and with the heavier fraction coming out from the bottom, it has higher boiling point. Means it's harder to make it boil. Whereas for the lighter fraction, it has lower boiling point, means that it's easier to be boiled.